Let's talk about water. I mean, it's everywhere, right? It covers most of our planet, it makes up most of our bodies. You think it's the most normal, familiar substance in the entire universe. But what if all that familiarity is just a mask for how incredibly, fundamentally weird it really is?
You know, the ancient philosopher Lao Tzu really hit the nail on the head with this one. Water is a total paradox. It can be the gentlest thing in the world, but it can also carve out the Grand Canyon. It's a substance of wild contrasts.
And that kind of gets us to the core question here. What if water's biggest secret isn't its power, but just how profoundly strange it is? We're going to dive into some of its biggest, most mind-bending mysteries.
And we're going to start small. Believe it or not, we can start with some seriously weird phenomena you can see right in your own kitchen, things you've probably never even thought twice about.
Okay, seriously, think about this for a second. You drop a stone in water, it sinks. You drop almost anything solid into its own liquid, it sinks. Solids are supposed to be denser. So why on earth do these gigantic mountains of ice just bob around on the ocean? Well, it's because water is a complete rule breaker. Ice is one of the only substances we know of where the solid form is less dense than the liquid form. This is a huge, huge anomaly. And honestly, without this weird quirk, life on Earth as we know it probably wouldn't even exist.
And here's the science behind it. When water freezes, its molecules lock into this beautiful, rigid, hexagonal crystal structure. But look at that, it's full of empty space. This structure actually pushes the molecules farther apart, making solid ice about 8% less dense than flowing liquid water. It's like it inflates as it freezes.
All right, next kitchen trick. You've probably seen this, maybe even done it. You can take a metal paperclip, which is way denser than water, and gently lay it on the surface, and it just sits there. It's floating. How in the world is that possible?
If you look really close, you can actually see the water's surface bending under the paperclip's weight. It's like it's resting on an invisible, stretchy sheet.
So that invisible skin has a name. It's called surface tension. Basically, all the water molecules on the surface are constantly pulling on each other, creating this strong inward force. It holds them together so tightly that it acts like a flexible membrane, strong enough to hold up that paperclip as long as you don't break the seal.
Okay, get ready for one of water's most baffling behaviors. This one feels like it breaks logic. You'd think, obviously, it takes longer for hot water to get down to freezing than it does for cold water, right? Well, you'd be wrong. Sometimes.
This is called the Mpemba effect. It's named after a high school kid in Tanzania who, back in 1963, noticed his hot ice cream mix was freezing way faster than his friend's cooler mix. He asked his teacher why, and nobody knew. Scientists were stumped, and you know what? They pretty much still are.
The honest truth is, we still don't have a single definitive answer. There are a bunch of theories, but one of the main ones has to do with convection. The idea is that in hot water, the currents circulate faster, which helps it lose heat more quickly. But for now, it's still a genuine, unsolved scientific puzzle.
So let's step out of the kitchen and take these weird water mysteries into the great outdoors, where things get bigger and a little more slippery. Here is another one that seems like it should have a really simple answer. People have been ice skating and slipping on sidewalks for ages, but after more than a century and a half of scientists studying it, we still can't agree on what exactly makes ice so slippery.
Now everybody agrees on the what. We know there's a super thin layer of liquid water right on top of the solid ice. That's what you're actually sliding on. The whole debate, the entire mystery, is about why that liquid layer is there to begin with.
And really, there are two main camps fighting it out. The first is the old-school pressure melting theory. It says the intense pressure from your tiny skate blade literally melts the ice right under it. But the other theory, the pre-existing liquid layer theory, says that, nope, the surface of ice is just naturally always a little bit liquid because its molecules are jiggling around so much. The jury is absolutely still out on this one.
All right, now for a way more dramatic effect. If you take boiling water and chuck it into the air when it's unbelievably cold outside, we're talking like negative 30 degrees Fahrenheit, it doesn't just freeze, it basically explodes into a cloud of snow.
Here's how it works, in 3 quick steps. First, when you throw the water, it breaks up into zillions of tiny droplets, which gives it a ton of surface area. Second, those hot droplets release a huge cloud of water vapor into air that's so cold it can barely hold any moisture at all. And so, third, all that excess vapor has nowhere to go, so it instantly crystallizes on tiny dust particles in the air, creating that beautiful poof of snow.
So, from a slippery pond to a cloud of snow, water is weird enough just here on Earth. But what happens when we leave our planet entirely? Let's follow water on its cosmic journey and ask the biggest question of all: where did it even come from?
You know, for the longest time, nobody even knew how water would boil in space. On Earth, when you boil water, gravity helps create all those thousands of chaotic little bubbles. But in zero-G, when they finally tried it, they found you don't get thousands of bubbles. You get one single, giant, wobbly, pulsating bubble. It's a totally alien sight.
And that brings us to the ultimate mystery. Think about it. When the Earth first formed, it was a molten ball of fire. Any water on the surface would have just boiled away instantly. So, where did all our oceans, rivers, and lakes come from?
Well, the leading theory for a long time was that it was a special delivery from outer space. During a period called the Late Heavy Bombardment, Earth got pummeled by icy comets and asteroids, which could have filled up our oceans. But there's a huge problem. When we actually go out and analyze the water from comets we can reach, its chemical makeup, it doesn't match our ocean water, which means the true origin of our planet's most precious resource is still a massive mystery.
So after this whole journey, from our kitchen sinks all the way out to the cosmos, it's pretty clear that water's simple, familiar surface is hiding some incredibly deep questions that we are still trying to answer. We've seen that the best and brightest are still trying to figure out why hot water can beat cold water in a race to freeze, what really makes ice slippery, and the biggest one of all, the true origin story of the water that makes our planet blue. These aren't small questions.
And that really leaves us with one last thing to think about. If water, the most common, most studied substance on the planet, still holds such profound secrets, just imagine what other everyday mysteries are out there, hiding in plain sight, just waiting for us to ask the right questions.